Hi, welcome to this page of the notes. We're going to go ahead and do another graphing problem. I take a look at what I got, and yeah, I got one of those scary looking ones. This is our piecewise defined function. I know that I'm going to need to graph this guy in pieces. And what I'm going to do this time is I'm just going to start off by taking a look at the inequalities that I was given. And it looks like these inequalities are centered around the number 2. My top function is going to be all values of x that are greater than 2. My bottom function is going to be all values of x less than or equal to 2. So let me go ahead, and like I did that first time we did one of these, there at positive 2, I'm going to go ahead and put that dotted line so that I know right there at positive 2. That's what's going to divide my top function from my bottom function. That's going to be kind of where this whole graph is going to center, right here at positive 2. All right, so here we go. Let's go ahead and get started. I will start with the top function. You don't have to. You could do the bottom function first if you want, but we'll do the top one first. So I'm going to start with f of x is equal to x plus 1, and let me set up my coordinates. All right, we're going to pick some easy values to work with. Negative, nope, I apologize, not easy values to work with. So sorry. You need to pick values of x that go with the inequality. This tells me that I need values of x that are strictly greater than 2. Strictly greater than 2. All right, well, that means that I need 3, 4, and 5. That should be plenty. Let's see what happens. I plug in a 3, 3 plus 1 is 4. I plug in a 4, 4 plus 1 is 5. I plug in a 5, 5 plus 1 is 6. Let's plot those points. 3, 4. 3, 1, 2, 3, 4 right there. 4, 5, 4, 5 right there. 5, 6, 5, 6 right. Hey, I apologize. Why is that black? Should be red. There we go. So I've got there, and there. Those are my points. Now I know that I'm strictly greater than 2. So what I'm going to do is I'm going to go ahead and throw 2 into my chart. But I know it needs to be an open circle when I graph it. So here's 2. Plug a 2 in for x. 2 plus 1 is 3. That gets me a 3. But this guy has got to be an open circle because it's strictly greater than. So 2, 1, 2, 3. Open circle, everybody going in that direction. Awesome. There's the first piece of my piecewise function. Let's go ahead and do the second piece. F of x, negative 2. Okay, x, y. All right, now for this second piece of my piecewise function, I need values of x that are I need values of x that are less than or equal to 2. So I'm definitely going to use 2 and 1 and 0, and why not? Let's go negative 1 just because they're easy to work with. Hold up, I apologize. Somehow I lost my x. Don't know how that happened. There we go. Okay, so I'm going to plug a positive 2 in. Negative 2 times 2. How about a minus 4? Great. I plug in a 1. 1 times a negative 2 is going to be a minus 2. I plug in a 0. 0 times a negative 2 is going to be a 0. Plug in a negative 1. Negative 2 times a negative 1 is going to be a positive 2. Let's graph those points. 2, negative 4. 2, 1, 2, 3, 4. Going to be a closed circle. 1, negative 2, right there. 0, 0, awesome, 0, 0, and negative 1, 2 right up here. Let's go ahead and draw a line connecting those points, extending all the way through my graph with an arrow on it so that I know you know it keeps going. And there we go. I've now graphed my piecewise defined function. The top piece gets me that graph, open circle, because it's strictly greater than, and the bottom piece gets me this graph, closed circle, because it's less than or equal to. Awesome piecewise defined functions. Guys, that takes care of all the problems in this set of notes. At this point, you should be comfortable with the step function, what it looks like, and how to graph it. You should be comfortable with the absolute value function, what it looks like and how to graph it. You should be comfortable with the piecewise defined function. They're going to look absolutely crazy. It changes every time, so there's no set way that they look, except you know that your graph is going to consist of multiple pieces. That's why it's a piecewise defined function. Thanks for joining me on this set of notes in these videos, and I'll see you guys next time.